Hello, and welcome back to Quantitative Reasoning Online. We just finished Lesson 10A, so I'm assuming you're here now for Lesson 10B, Preview Assignment. So let's see what it looks like. So Preview Assignment for Lesson 10B, interactive tutorial is something called, Is it getting crowded? Gee, I don't know. Is it? Let's take a look. So let's see, preview, calculate first differences, determine an average growth rate. Okay. Here's a secret for you, basically slope. And graph data and describe the shape of a graph. Average growth rate is basically what's meant by we have some data, and it's not a perfect straight line, okay. Or even better yet, it's basically this one, but you're just looking for the average growth rate between two of the points. Well, basically what you're doing is doing a straight line approximation, finding the slope, and essentially no matter what the function looks like or what the relationship looks like between A and B, the average growth rate between A and B is the slope of the line between coordinate points A and B. We'll get there. So in this class, you will continue to develop time series models. Oh, that's fun. The tutorial for the preview of Lesson 10, Part B, Is it getting crowded? The world, that is, begins here. We call that time series is a sequence of data points measured typically at successive points in time. So, which means my x-axis, my explanatory, is time. And it's based on uniform time intervals. It could be days, hours, minutes, years, centuries. All depends on the time scale you're using. But being a time series, 1 to 2 is from 1 something to 2 something, either 1 minute to 2 minute, 1 hour to 2 hour, 1 year to 2 years, 1 millennial to another millennial. Example of time series are daily closing values of the Dow Jones Industrial Average and the annual flow volume in the Nile River. So daily, okay. So here time is measured in days, annual measured in years. Time series models are frequently plotted using line graphs. Very good. All right. Okay, so graphs are fun, but the growth of the world's population may be more important. Complete the Part A portion of the table by finding estimates for world population in 10-year intervals from 1950 to 2010. Label this data P. Be sure to note the source of the estimates, for example, the web address where the estimates were found, and if possible, the original source of the estimates. So let's go do that. Okay. Now, for this, I went on some web searching, and basically I settled on, oops, wrong button, on this site. I just did world population, 1950 to present, something like that. And I had to go look at a couple of sites, but I found this guy here. So let's see, how does this compare? Wrong one. So one donation. So let's see, this one says 1950 was 2556, 2557, close enough. 3042, 3049, oh, nuts. Right. So let's see. So let's throw some numbers in. Let's 1970 was, does it go away? I hope not. 3706 618 163. So 3,706,618,163. Wow. 1980 was 4,453,831,714. It's going up. 1990, 5,278,639,789. Really, they really down that kind of a detail. 2000, 6,082,966,429. And 2010, 6,848,932, 848,932,929. Yeah, looks like we have regular boom here, but looks like the population rate is going down. The rate of increase is going down, I should say. Interesting. Okay, solution. Okay, use some table. And what was theirs? I said 3,706,000,000. Okay, 712 million, little low. 4,450,000,000. My source is 453 million, a little higher. Oh, this is real close. 5,287,000,000. Some difference in the thousands. 6,090,000,000. That's 6,082,000,000. 6,806. Okay, 66. Mine was 86. We got close. We got close what their numbers were. Again, different sources, maybe a little bit different. Do you use a UN, United Nations numbers, something based on the U.S. Census? What was their solution? Something the U.S. Census. Mine came from the site. There you go. Total population of the world by decades, 1950 to 2050. So, different sites may have slightly different numbers, but they're all in the same ballpark. Okay. For each. Yeah, just part A. We'll probably do C and D later. Alright, create a spreadsheet of your data and use the spreadsheet to create a line graph of the data. Save the spreadsheet and the graph to your computer. Describe the shape of the graph. So let's go back to our data. We need to create a graph of it. So let's go back to my data was. And nice about some of the stuff, you can kind of just do a copy. Have an Excel spreadsheet open. Do a paste. All that means I need more space. All right. So now we want to do a graph. All right. Well, I want it done over the years. Some aberrations came through. So let's do a graph. This is my X, there's my Y. And let's insert it into A. And there's our graph. What kind of graph do you want us to do again? A line graph of the data. All right. So I got to go back and let's do this over again. Same data. Insert, chart, and a line graph. Here we go. And there is our graph. Should always have some years. World population. Things to look at in this graph. Wow. I can see how there's a little bit of curvature here, straightens out, and I see it starting to bend down. Bend down. So it may be flattening, who knows? So what do they want us to do here? Save the spreadsheet and graph to your computer, describe the shape of the graph. Oh. Well, increasing, goes sort of linear and starts decreasing less. Graph here have slight curve, then start to look more linear. So I think it's what I said. Curving up at the beginning, goes linear like in the middle, and looks like it starts to see your R curve down column at the end. It basically looks like it's going to do something. All right, give me a break. Okay, doesn't want to do the, let me draw it. That's okay. So we got that one figured out. Next question. Calculate the difference for the data set, which is also referred to as the actual growth value. We will label these values R. Okay, I'm going to do this on the spreadsheet since it's going to be a little difficult to here. So let's go to spreadsheet. So let's close this guy out, close this guy out, move this guy over, and let's give ourselves a new column. And what's the column going to be? Column is going to be called First Differences Actual Growth. Differences actual growth. And that is just going to be current year minus the current decade minus previous decade. So all we're going to do is look at what is where I am minus where I was. Okay. So between 1960 and 1950, the world population had a growth of just under half a billion, almost 500 million. Same thing here. To find out what the change from 70 to 60 is, we'd take 1970 and we'll subtract 1960 from it. So from 1960 to 1970, the world population had a growth of 667 million. I'm just going to go and use the Excel function to repeat the equation. So let's see what we have here. So for 2000, this number is going to say, all right, I'll take the 2000 population, I'll subtract 1990's population from it, for a change of 804 million more people. Okay. So what's the answer here? So 1970, they're saying about 669. My Excel says 667 million. For 2000, it was about 802 million. 2,804 million, based on the numbers that we had. 2010, from 2000 was 775 million. 2010 to 2000, 765 million. So you see how the actual growth is. Okay. For 60 to 70, it was more. 70 to 80 was more. 80 to 90 was more. 90 to 2000 was actually less than the previous growth. 2000 to 2010 actually had a decrease in the growth rate. 2020, less. 2030, even less projected. Wrong button. We label these values R. Okay. That's your growth rate. R. Next one. Okay, now calculate the percentage growth for the data set. Round your answer to 2 decimal places. Note that this is the percentage growth over each 10-year period. Okay. So now this is going to be like what we did a lesson or two ago when we find percent error or percent change, when we had the estimated minus calculated over calculated. Well, percent change here is going to be what's showing up here is R, okay, divided by the previous 10 years. So, for example, percent change from 2000 to 2010, well, would be the change of population from 2010 to 2000. So whatever the population of 2010 was minus the population of 2000, okay, divided by, well, what are we comparing it to? I want to compare the change from 2000. So over here, notice how minus calculated divided by calculated. Population of 2000 divided by population of 2000. Okay, say the same. Should be a 1, by the way. Better looking 1. So let's do our Excel. See if we get the same thing. Okay. So what are we calling this over here? Average growth rate. All right. Again, that'll be okay, yeah. So average growth rate is going to be what the difference was. The difference between 60 and 50 divided by what are we comparing it to, the previous decade. Zero. Again, what is 483 million divided by this guy. He thinks it is the cell format. Yeah. There you go. All right. 18.91. Of course, this guy would be, okay, what was the difference between 1970 and 1960 divided by 1960? And same thing. $21.95. So we can just go down the rest of the way. All right. And of course, percentage would be to just take the previous number and times by 100. What's my times? E4 times 100. Oh, there we go. So about 19%, 22%, 20%, 18.5%, 15%. All right. This table here, I must be looking at, gee, from 1950 to 1960 was 18, 60 to 70. Let me get rid of this guy. All right. So that's what they get. So for 1960, from 1950, about 18.1897. 1960.1891 with my data. 2000, so from 1990 to 2000 was a 0.1517. 2000, 0.1524, 1527, 1524. So in the same order, 17. All based on the data. So the data looks pretty good. So the differences between the decades, it'll just be the current decade minus the previous decade. Average growth rate is be what is that difference divided by the previous population, previous decade. Next question. Create a scatter plot with the world population on the horizontal and the percentage growth on the vertical axis. How does this scatter plot compare to the expected graph if the population were growing exponentially? So create a scatter plot with the world population on the horizontal, that means X, percentage growth on the vertical. Okay. So let's see. Whoops. Move this guy over here. Do another graph. And I want world population on the horizontal, and what on the x-axis, y-axis, and the percentage growth. And I guess I should name this percentage growth. Okay, so let's have, there's my x-axis, and is the shift? Nope. Highlight the first one for your x, hold down the control key, percentage growth. And let's do an insert. And there's a graph. Actually, I had this one correctly. Uh-oh. Yep, world population horizontal, percentage growth on the x. Go away. World population percentage growth. GROW growth. Okay, and I expand it out a little bit. Here we go. All right. So it looks like we were growing, hit a peak, growth rate, and the growth rate's been basically steadily declining since, I'm not sure since when, 1970, I guess. Let's go, what is the question? How does the scatter plot compare to the expected graph if the population were growing exponentially? Okay. Well, if the population was growing exponentially, one would expect, if it was growing exponentially, one would expect that, and this ain't going to go up. Will it? No. One would expect this data, the actual growth differences, to be constantly getting larger and larger. So like 483 million, 500 million, 600 million, 700 million, 800 million, 900, a billion, 2 billion. So that the growth rate should be going up. Because here's T, here's population. So for any given constant time of year, I would expect this gap to keep increasing. So the scatter plot does not show me a population that is exponentially growing. The growth is slowing down. Or the rate of growth is slowing down. We're still growing, just not as fast. How do our graphs look? Actually pretty good. Yep, there's a little dip there, little dip. Went out a few more years, projected out. All right, looks pretty good. How do you put it? Nuts. World population, percentage growth. Hey, we actually got the titles correct. Love it when that happens. All right. Okay, so let's see. How confident that you can calculate the first difference? Real confidence. You know, basically, who I am minus who I was over average growth rate. Okay, basically my calculate first difference divided by the population of where I was. And graphing, that comes with practice. Okay. Doesn't go come practice. Okay, and also kind of like showed. Let's see, how can I get this going? Here we go. How it was kind of like curved, still kind of like looks like a curving up here. You know, that basically means an increase. Kind of straighten out. You know, that's kind of the linear part here, and kind of like curving down. Maybe need to go out a few more data points. Maybe I didn't go out enough. Maybe not go out far enough to show that this curve is actually starting to pull down faster. So this shape and this shape do correspond to each other. Okay, enough of that. So let's see, we calculated first differences. And that was that was this one here. Hey, the difference between 1960 and 1950 to 1970 and 1960. Just find the change in population between those 2 decades. We determined the average growth rate, and we graphed the data and described the shape of a graph. I think we met the intent. And that's actually lesson 10 completed. So, Here we are, completing the interactive tutorial for 10B. Please go back and look at the video, the interactive tutorial again on your own. Think about it, what was being done, how it was being done. And I'll see you shortly for doing the whole one question, maybe more than one part though, in short moments. So look over these here, look over the interactive tutorial again, and then come back and see me for question 1. Help.